Guys, this is me Ajit and this is the first video of our machine learning course. So basically you are going to get n number of videos on this channel. So that is why I'm requesting you to please subscribe my channel first. Now before jumping into the algorithm section of machine learning, first we have to develop a better understanding of some libraries like NumPy, Pandas, Matplotlib and Seaborn. So in the first video we are going to talk about NumPy. So you can download NumPy from their official site or you can simply install it from your terminal too. So I'm just showing you that how you can install NumPy from your terminal. What you have to do, that you have to write pip, I'm just zooming it in, pip3 install NumPy. And as it is already installed on my laptop, that is why I don't need to install it again. Now I'm going to open my Jupyter notebook. And well, I'll create a new notebook here. So first of all, we have to understand that what is NumPy. Well, NumPy stands for numeric Python, and NumPy is the fundamental package for computing scientific operations in Python. Well, it is a Python library that allows us to create multi-dimensional array, and using NumPy makes it quite easier to deal with array operations, and we can solve array operations in very little time by using NumPy. Before using NumPy, first we have to import NumPy. Oh, sorry, type it here. Import NumPy as NP. Well, you can use any name instead of NP. Well, but it will be good if you are using NP because most of people out there are using NP as the abbreviation. So how can we create an array using NumPy? So simply what we have to do is np.array. We can pass any list here like 1, 2, 3, 4, 5, and here we got our array. Now we can pass any list to, like I'll create a list, name my list is equals to 1, 2, 3, 4, 5 and np.array my list, and here we can see that this will also give us an array. So simply we can pass a list as a parameter, or we can create a variable which is of list type and we can pass that variable as a parameter to that array method. Now a question might pass you by that we already have list in Python, so why do we need NumPy? Like we can do all the operations of array with the help of list too, so why do we need NumPy? So the answer is NumPy array consumes less space than list, and the second one is NumPy array is faster than Python list. Well, these are the two least important things which makes NumPy useful than Python list. So what is the main point which totally differentiates list and NumPy array? So we can perform arithmetic tasks on NumPy array, but we cannot perform arithmetic tasks on Python list. Well, I'm showing you this. Like first I'll create an array and a1 is equals to np.array 1, 2, 3, 4, 5, and I'll create another array five, and when I simply add these two, I'll get another array, and here we see that the array which we get as an output is simply the addition of these two arrays. But what will be the answer if we are doing the same operation on Python list? Like, I'll show you this one. Create a list, L1 is equals to 1, 2, 3, 4, and another list, L2, 5, 6, 7, and 8. And when we perform the same addition operation on L1 and L2, and we check L3, here we see that it performs the concatenation operation rather than adding these elements of both the list. So this is the basic difference of Python list and NumPy array, that on NumPy array we can perform arithmetic operations, but on list we cannot perform any kind of arithmetic operations. Now I'm showing you the ways by using which you can create multidimensional arrays. What we can simply do is, first we will create a multidimensional list, like my list was 1, 2, 3, 4, 5, 6, 7, 9. So it is a 3D array. I'm creating a 3D array, np.array my list, and here we can see that we have created a 2D array. Now we can simply create this by passing the list by itself in this. And here we can see that we get the almost same array here. So these are the two ways by using which we can create multidimensional array. Now, like creating arrays by passing list and doing all these things is quite tedious. So there are some built-in methods by using which we can create arrays too. So now we are going to see that what are these methods. So the first method is arange. So how arange works? Well, writing it down here. Well, we can pass three parameters in the arange method, and the parameters are start, stop, and step. Now, what does this start, stop, and step symbolizes here? Well, start means from where we have to start, and stop means where we have to stop, and step means the steps to take after start. Now, I know that it is not clicking into your head that what I'm saying, but we can see this with an example. Like suppose I'm creating an array by using the arange method, and the start is 1, 10, and the stop is 10. So I'm getting an array which starts from 1 and ends at 9. So what we are seeing here, that we got an array which starts from 1 and ends at 9. So what this simply means is start is included and stop is excluded. Like we want to create an array of first 50 natural numbers. So what we have to do is we have to use the arange method as 1 to 51, and we got an array of first 50 natural numbers. So what here we have to keep in mind, that we have to use 51 as stop parameter. Why? Because stop is excluded and 51 is not included in this array. So that is why we have to pass 51 instead of 50. Now I'm showing you an example where we can understand that what does this step do. So like suppose that I want to create an array which contains all the even numbers which are lesser than 50. So what I can simply do is np.arange 1 to 51, and I'll simply put a step as 2, and No, my bad. Here I have to use 2. And here we can see that we got all the even numbers which are smaller than 50. And what does this step means? Like I'm taking a step of 2. Like I've taken 2, I've skipped 3 and then 4. Skip 5 and 6. Skip 7 and 8. And if I take step as 3, it will simply give me an array like we take 2, skip 3, 4 and take 5. Like we are taking a step of 3. If we take step 4, then we are getting 2, 6, 10. We are taking a step of size 4, like we are skipping 3, 4, 5. So this is what step does. There's a built-in method by using which we can create an array of all zeros, and that method by itself is called as zeros. Like here, I'm showing this with an example dot zeros, and what I have to do is just pass the number of zeros which I want to be in my array. Like I want 5 zeros in my array, so I just pass 5. What if we want to create multi-dimensional array with zeros? So simply we can pass np dot zeros and 3 by 3. So we get a 2D array of all zeros. We can also pass tuple as a parameter to create multi-dimensional arrays with all zeros. Like I'm showing you one np dot zeros, and I'm passing a tuple here 3 by 3. Here we can see that we got a 2D array with all zeros by passing a tuple as parameter. Now what if we want to create an array with all ones? So we can simply use np dot ones. The ones method is used for creating array of all ones. Like I'm passing 4, so we can see that we got an array with all one. And like what we have done with zeros, we can create multi-dimensional array having all ones. So I'm showing you now np dot ones 3 by 3. Here we can see that we got a 2D array which contains all ones. Linspace is another method of NumPy, and linspace is quite useful when you are using machine learning algorithms. So I'm just showing you the syntax of linspace. Start, end, and number of partitions. So linspace stands for linearly spaced. Like it is used to generate given number of linearly spaced partitions between two specified numbers. Like I'm showing this with an example. Like suppose np dot linspace 0, 5, 10. So what it simply does, that it generates 10 equal partitions between 0 and 5, where both 0 and 5 are inclusive. Here we can see that 5 is not excluded. It is not exclusive, just like the arrange method. Here 5 is included too. Like suppose when we are dealing with machine learning algorithms and we want to create equally linearly spaced partition between different data sets. So this linspace method will be quite handy at that time. So linspace method is what by using which we can create or we can generate linearly spaced array. Well, identity matrix is used everywhere, whether it is digital image processing, machine learning, deep learning. Identity matrix has made its space everywhere. NumPy has a built-in method by using which we can create identity matrix too. So now we are looking that what is that method. So we can simply create identity matrix by using the I method, np.I, and we can simply pass 3. So here we can see that for creating multidimensional identity matrix, we do not have to pass tuple as a parameter. We just have to pass an integer. Like I want to create an identity matrix of 4 by 4. So what I have to do is just I have to pass 4 as a parameter, and here we can see that we got an identity matrix of 4 by 4. Now that's all for the first video. In the next video, we are going to talk about the random library. Well, we have already seen random library in Python, but we can use it with NumPy too. So thanks for watching this video, and if you like this video, just like it and don't forget to subscribe my channel. Thank you.